Hello, everybody. I think we had a problem with the banner. This is indeed the App Service Community Stand-Up, not the CLI. But welcome. Thank you for being here. And we have a packed show today. So we're going to have Daniel from the .NET team, who's going to be talking to us about .NET 9, as well as Jeff, who's going to be teaching us about app configuration and how to integrate that with App Service. So packed show. I'm going to keep it short. Let's go ahead with your stuff, Daniel.
All right, awesome. Thanks for having me on the show. It's great to be here with you all. Yeah, I'm going to talk a little bit about .NET 9, which is the next major release of the .NET platform. We're actually getting pretty close to being done with .NET 9. We're putting the final touches on the release candidate, first release candidate of .NET 9 that should become available here in just a week or two. But the news for today is that you can actually try out the latest. A very recent .NET 9 preview on Azure App Service. The Azure App Service folks have kindly deployed a .NET 9 preview to Azure App Service for Linux, and they're in the process of also rolling that out for Windows as well. So I thought we would take a quick look at that, about how you can try out .NET 9 on Azure today. So if we could bring up the portal here, let's take a look and see how you can set up an Azure App Service web app to use the latest .NET 9 preview. There we go. Okay, so this is the portal. And if you just go to create a resource and create a web app, in here, you should be able to, if you just scroll down to the runtime stack and you have a bunch of options, you should see an option now for .NET 9 STS preview. STS stands for Standard Term Support Release. This is our latest release of .NET 9. It's available on App Service for you to try out. If you select that, you'll notice that it'll automatically select Linux for you, because that's the only place where it's currently supported, but Windows is coming soon. Now, this version of .NET 9 is .NET 9 Preview 6. It's one preview older than what's currently available. If you install Visual Studio or the latest .NET 9 preview, you'll actually get .NET 9 Preview 7, but it's pretty close. And all the features that I'm going to show today are absolutely working in the .NET 9 Preview 6 build.
Yeah, and here I have that this is a floating release. So whenever .NET 7 rolls out through the platform, your apps get auto-updated to Preview 7, RC, RC1, etc., all the way up to GA.
Yeah, the platform just updates underneath your application. Cool. Yeah, great. So here's a Blazor web app that I've already gone ahead and deployed to Azure App Service. I created a web app instance that's got .NET 9 provisioned on it. This is the application running, and it looks great. It's working fine. Here's another example. This is just a web API that I built and deployed, again, running on .NET 9 Preview 6. Here's the code for that Blazor web app. You can see in this case, this Blazor web app is actually it's using both client and server functionality. It's actually using the new auto render mode that we introduced in .NET 8, where you both can run your components from the server and then transition them to run on the client on WebAssembly. Now, in order to get started with building apps like this and deploying them to Azure App Service, there are a few things that you might need to do to set up your dev machine so you can work with .NET 9 Preview 6. You'll notice that I'm actually using the latest preview version of Visual Studio. I've got 17.12 Preview 1 installed, which is what you'll want to use. You'll want to install VS Preview instead of using the stable version of VS. But this will actually come with .NET 9 Preview 7 pre-installed. So if you try to create a new project or build a project, it will use those Preview 7 bits. So what you want to do is actually go and install the .NET 9 Preview 6 SDK. We get a browser up here. The easiest way to do that is you can go to get.net/9. So get.net 9. See that? Let's zoom in a little bit. That's the magic URL. And then if you go to that, that will bring you to the .NET 9 downloads page. The top one will, of course, be the latest preview, which is Preview 7. But if you just scroll down a little bit, you'll see the Preview 6 downloads that you can grab and install. You'll want to grab the SDK. And if you're on Windows on a 64-bit machine, that's the link right there that you'll want to use. Once you've got that installed, and I've already done that. Go ahead.
Sorry, if you have a pretty bad memory, we post a blog that has all of the links that we talk about during the thing, so you can also go find it there if you need it.
Yep, absolutely. If you've got that installed, and I've already done that, if you run like .NET list SDKs on your command line, you'll see all the versions of the SDKs you now have available. I've got .NET 8 installed, of course. That's the latest long-term support release. .NET 9 Preview 6, which I installed manually, and then .NET 9 Preview 7, which came with Visual Studio. And then in order to make the Preview 6 SDK the active SDK, you're going to want to create a global.json file and just set that SDK version as the active SDK version. I've actually got one of those right here. I'll just open that up for you so you can see it. So here's my global SDK file that's pinning the SDK to Preview 6. So just so that that's the active version when I build and run and deploy.
Right.
When you're if you don't want to remember that specific JSON syntax, you can actually do .NET new global JSON, just like that, all one word, no dot, and it will generate a global JSON file for you, and then just copy the version from the list SDK output, and that will set you up there to have that be the active SDK, and that'll work both in the command line and in Visual Studio for whatever folder that you stuck that global JSON file. What you can then do is you can take if you have a .NET 8 app that you want to update to try out with .NET 9 Preview 6 and deploy it, you can then just retarget it to target .NET 9. Like here in my Blazor web app, you can see up above, I'm using Net 9.0 as the target framework. And then over here, all your package versions, you're going to want to make sure you're using the Preview 6 versions of those packages when deploying to App Service. And so you can do that update manually to your existing applications. If you want to create new ones, there's a little trick there as well. Once you've installed Preview 7, you'll get Preview 7 project templates. And so every time you create a new template, even if you're using the Preview 6 SDK, you'll still get Preview 7 versions of those apps. What you can do instead is you can install the Preview 6 templates from NuGet, and that will let me bring up this page over here. So if you go to the NuGet gallery and find this package, this is actually the template pack for the for all the web ASP.NET Core templates that ship in the SDK, and you can see all the different versions here. If you select the Preview 6 version, there'll be a command that you can copy right here for installing those the Preview 6 versions of the template. So you just copy this and then go to your command line and go ahead and run that. Now, if you have the preview, looks like I need to actually get that again. Okay, got it copied. There we go. Now, if you just run it as is, it will actually complain and say, hey, you've got Preview 7 templates installed. You need to pass in the -- force option to really make it happen. So if we do -- force, that will now install the Preview 6 versions of the templates, and that will work on both the .NET CLI and also in Visual Studio.
Are they side by side at this point, or is it one or the other?
It's one or the other. You really have one active set of templates, regardless even of which SDK version you have going. It'll just always pick, by default, it'll pick the latest version of those templates. If you install a template pack like this, it'll basically pin it to this version. So when you're done, you are going to want to then uninstall the template pack to get back to whatever version of the templates you have with your SDK. And that's easy to do as well. You just remove the version from the package ID, and instead of running .NET new install, .NET new uninstall will revert you back to the Preview 7 version of those templates. Cool. So that's how you can get your machine set up to work with .NET 9 Preview 6, and then you can deploy those to those apps to Azure, and they'll work great. If you prefer instead to use the latest version of .NET 9, like whether it's Preview 7 or the upcoming release candidate, you can do that too. We have instructions in the ASP.NET Core docs. I'll just go to docs.asp.net. We'll just click a random link here so we can get to the table of contents. Down here, kind of near the bottom, there's this host and deploy section and Azure App Service overview. All right, so that's where you want to go. And once you get to that doc, in this section, you'll find this subsection about deploying ASP.NET Core apps that use a .NET Core preview. And if you click on that, you can find instructions here on how to deploy the app self-contained, which basically means you're bringing the runtime with you to Azure instead of relying on it being deployed there, or you could use a Docker image and so forth. So instructions here if you want to use a newer version of .NET 9 as well. Okay, so that's how you can get to your bits up and running just like I did.
I have one more. I know, shame on me, but I don't have the latest, greatest version of Visual Studio installed, but I do have VS Code. And VS Code with Preview 6, I can just do .NET New MVC and it does the right thing. As long as I don't have multiple preview versions of .NET installed, I don't need to do a lot of this
other
fucking around.
shenanigans.
Yeah. Shenanigans.
Yes, no, that's true. Yeah, I mean, Visual Studio Code, if you install Visual Studio Code with the C# Dev Kit extension,
Yep.
you actually get a really great .NET Dev experience in Visual Studio Code for those of you out there who prefer that sort of lightweight editor experience. And Visual Studio Code and C# Dev Kit doesn't bring with it the .NET SDK. So you just install whatever SDK you want at that point, and then all the normal default experiences will just work. Just make sure you install the Preview 6 version of the SDK, not the latest one.
Yep.
Yeah. Okay, cool. So I thought we would now look at some of the new features that are actually in the .NET 9. Like what should you try out? Well, let's first look at the new render mode API that we've introduced for Blazor Web Apps, so you can detect how your components are rendering at runtime. As we were just looking before, Blazor Web Apps can render components in all sorts of different ways. They can render them statically from the server. Like you send a request, you get some HTML from the component, and that's it. No WebSockets, no WebAssembly. You can render them interactively from the server. That's where we set up that WebSocket connection with the server, so we can handle UI events and push updates down to the browser over a live connection. Or you can render them interactively from the client on WebAssembly, where you actually download your code and render them on a .NET WebAssembly runtime. If we go back to the app, we can see all that actually happening. So here, this app, if I go to the counter page, this home page is just a static page, but if I go to the counter page, you can see I've set it up. Maybe you saw it really quick. Like this render mode heading is displaying what the current render mode is for this page. Like briefly, it said static. And then it switched over to server. So if initially that static render was actually a pre-render where the page rendered statically from the server. We got a batch of HTML down to the browser. And then the Blazor script booted up on the client. And it set up this component to be interactive using, well, this says interactive server. So it's got a WebSocket connection so that when I click this button, that event can be handled. It gets sent to the server, the component renders, and so forth. Now, if I browse away, back to the homepage and then come back, because we're using that fancy auto render mode, in the background, we actually downloaded the WebAssembly runtime and cached it. And so the Blazor app detected that and said, oh, I've now got the WebAssembly runtime. It wasn't there before, but it was downloaded and cached in the background. And so it automatically switched over to using it. And you can see now we're on the WebAssembly render mode. And again, it's still working as before. So we kind of pushed that load from the server to the client. Now, how is this working? Like, how is this code running? And I should also point out, let me refresh one more time. Now watch the button real quick. Initially it says static and the button says like, wait for it. Let me do it one more time. So maybe I can catch it in the, there. Okay, I froze it. So right now it's doing an initial static rendering and the button doesn't show up because if you click the button while it's statically rendered, it won't handle any UI events in that situation. But once the app, boots up on WebAssembly, if we let it continue, then it switches over to WebAssembly and we see the button again. So I'm actually changing what's rendering based on whether the component is currently interactive or not. So how do we do that? In the code, if we go to that counter page, so up here at the top, we can see that, we'll do that a little bit better. Up here at the top, we can see there's the render mode being set to say auto, use the WebAssembly runtime if it's there. If it's not, use server and then download the runtime in the background. Right. And then here, this render info API, this is new in .NET 9. This lets you inspect at runtime what the current render mode is. And here I'm just displaying the name. Right. But down below, I've got some logic where we grab the renderer info and ask, is the current render mode interactive? If it is, then we render the button. If it's not, then we just put some placeholder text. Or you could imagine disabling the button or just doing something different that's more appropriate for static rendering, given that you're not currently interactive. So that's the new render info API where you can detect the render mode at runtime. Yeah,
so this is pretty cool because I don't need to necessarily choose one with the auto. It will handle the fact that it's the first time it's loading, it's preloading, it's coming back, give you the best experience, and then you can also handle it depending on where you are in that journey, right? So this is making it very flexible for you to know where you are and what's the right thing to render.
Yeah, and for component authors, if you're trying to figure out how do I make my component fully functional in all the different ways that it might be rendered. This is another tool in your toolbox where you can control what the DOM elements it produces are based on whether or not you have interactivity available to you. So that's one. Another one I'll show. Let's see. I think what we'll do is let's look at the. This one's not specific to Blazor, but it does actually help Blazor apps as well. We've done a bunch of optimizations in .NET 9 for how ASP.NET Core handles static files, like think JavaScript files or CSS files that are part of your app. Historically, we've always had this static file middleware that you point it at some place on disk and say, hey, these are the files I want to be available over the internet. And a request comes in. If the path matches, it will serve that file. That's a little bit oversimplified, but that's how we've done static files in ASP.NET Core for a long, long time. In .NET 9, we're making that experience better by first observing that, most of the time, those static files are known even when you're building the app or when you're publishing the app. They're kind of a fixed set. Most people aren't dynamically generating those files. In some cases, that still might make sense, and there's ways still to do that. But given that most of the time they're known, we can actually, during build and publish, collect all the information about those static files and make that information available so we can optimize the behavior of the app. First of all, is we can make all those files available as proper endpoints using like endpoint routing. So you can associate metadata with them, like whether or not you want requests to them to be authorized. Like you can add authorization rules to those static files now. We can also do a bunch of optimizations on those files. Like we can pre-compress them as part of your publishing flow so that they're as small as possible. I mean, yeah, you could use compression at runtime, which a lot of servers will do. But by pre-compressing them as part of the build, you can really crank up the pre-compression rate and have it be as tight as you can possibly make it using like broadly compression. We've supported pre-compression in Blazor WebAssembly apps for a long time, but now this pre-compression is for really any static asset that you have in any ASP.NET Core app that isn't already compressed. Obviously, we're not going to compress like images and fonts, like things that already have a compressed file format. But like JavaScript files, CSS files, those types of things, we can make them much smaller. And we can also fingerprint the files so that they have a unique name when they're actually published. And that allows us to then avoid them being accidentally cached in ways. Like if you publish an update to that file and you've got a stale version that's maybe being served to your client and you don't want that to happen. And we can aggressively cache the fingerprinted file names. So, okay, that's a lot of talking. Let me show you what I mean. If I go, let's just go to the homepage of this Blazor app, and I'm going to bring up the browser dev tools. Let's go to the network tab, and I'm going to empty the cache and refresh the app so we can see what's being downloaded on the first load. So, okay, first thing to notice is here's all the files that are being downloaded. We can see they have those fingerprinted file names. They have these little content-based hashes that are being added to the file name so that they're unique. If the content of the file changes, then this file name will change. Otherwise, it's stable. So we avoid accidental caching issues. And then we can know that every time I publish the app, this file will have a unique name if it is actually different. And that enables a whole bunch of useful things like caching them. If we look at this bootstrap.min blah, blah, blah.css file and look at its cache control headers, we can see that we're serving this file and saying, this is immutable.
Yep.
This file will never change. If it changes, I'm going to change the file name. So go ahead and cache it basically forever, browser. And if the browser doesn't support immutable, then we tell it we'll cache it for a really, really long time. So you get really great caching behavior. We're also generating content-based e tags for these files. So like if the file is a built file from some other asset, but the build output didn't actually change, but the last modified timestamp did. In the past, we would use a last modified stamp and you would get a cache miss. Now you'll actually get a cache hit for those files as well. The content length for this file is nice and small. It's only 17K. If we go back and look at what the actual resource size is, you can see it's 163 kilobytes. And that's because we've pre-compressed the file using as small as possible. So the download is smaller, the app loads quicker. So those are all things that are now enabled just by default when you're using static files in an ASP.NET Core app. There is some new code that you add to turn on these features in our templates. I should say they're enabled by default in our new templates. If you have an existing app that's using static file middleware, still using that old middleware, but you can update it to use the new API, which is right here. So what you do is you call map static assets. So that will map the static files to actual endpoints in your application and do all those optimizations then. When you want to refer to those files as part of your app, if it's the framework that's referring to those files, like like the component specific style sheets or other things like that, where we can control the file names in ASP.NET Core, we automatically will use the fingerprinted file names for you. If you need to reference those file names directly yourself, we give you APIs for doing that. Like if we go in app.razor, you can see when I'm referencing Bootstrap, I have this new assets API where I use the original file name, and then the framework will figure out what the actual fingerprinted file name is for you. So that's the way you can do that yourself. Yeah. Oh, and you might be wondering about what about JavaScript files where I'm doing like JavaScript imports, and the file name is now being changed to some other fingerprinted file name. This new import map component right here will generate an import map that will map the original file names to the fingerprinted file name. So that all works as well. Perfect. And there's a tag helper version of this for MVC and Razor Pages apps too. Okay. Great. So that's static web asset optimization. We're now way more efficient and clever about how we deal with the static files in your application.
No, and this makes a big difference, because on the app service side, when we start looking at an app where we get customer complaints that there's too much CPU being used and stuff like that, we start looking at what can we do to offload work from the web server, right? And doing all of this pre-compression ahead of time means that it's not every request where the file's not changing, yet we end up having to recompress it on the server if you don't have the right caching policies and all of that in place. So this takes it all out. It's done at build. You do it once, and then is served efficiently. And when you have a lot of volume data, this adds up, right? Even if it's like a couple of milliseconds for every request, it just adds up exponentially with the volume of your traffic.
Yep. It's all about making it more efficient. We also don't have to keep checking the disk every single time when we're just looking for the file, because we've already collected that information as part of the build or publish step. So that's also more efficient. Yeah, that's the idea. Okay, so that's static web asset optimization. One more thing I'll show is the new open API support that we've added for people building APIs with ASP.NET Core. I have an API that's already published to Azure. So here's a simple little like weather forecast API. It's just returning some weather data. And this is running on .NET 9 Preview 6. And it's using our new built-in support for generating open API specs. Open API specs are a really convenient way to describe your API surface area using a standardized JSON or YAML format, and we now can generate these specs as part of the framework that is ASP.NET Core. In the past, we relied on a external community library. There's a library called Swashbuckle, which is still a great library. I think Swashbuckle went through some issues with the project ownership. Like they were trying to, the original owner wanted to move on. And I think they have now found a new project owner. But we decided we really wanted to bring open API support closer to the framework for a number of reasons. Like it's important for like API management. It's important for in the new AI world. Like if you want to expose API endpoints like this to large language models so that they can call them like through plugins like in Semantic Kernel. That's all done using open API specs. So it's really becoming a more critical part of the platform. So we decided, we really need to make sure that this is in and stable and good and being well maintained. So how do you set this up in your web API? Let me show you that real quick. So here's a .NET 9 Preview 6 API. I just did file new project on the template, and up at the top, we have these calls to add open API. This adds the open API services. And then to actually set up the endpoint for the open API document, you call map open API. And that's really it. The package where that's all coming from is the Microsoft ASP.NET Core Open API package. So that's the package you need to have in your app if you want to use this new Open API generation support. And it has a whole bunch of features, like you can customize the Open API spec as it's generated. You can choose to generate it at build time if you want to, and so on. But this will basically inspect your API endpoints and then produce the right spec. Now, we don't currently support the Swagger UI, which was sort of like a little mini web app that you could package with your application to like test the API endpoints. We decided not to do that. You can still use the Swagger UI from Swashbuckle if you want to. You can wire that up and point it at this OpenAPI doc, and that will work. But there's actually a bunch of features already in VS for testing your API endpoints that you can just use instead. Like you'll notice there's this HTTP document sitting over here in the Solution Explorer. Well, that looks terrible. There we go. That will open up this file, which has like some sort of like templated out HTTP requests that you want to send to your API endpoint. So if I get this running, there we go. Okay, so there's the app's now just running locally on my machine. And if I click this like send request button right above this get to the weather forecast endpoint, I can do test requests to my API endpoints from right here in Visual Studio. There we go. So now I can see, the response and the raw data and headers and so forth. And there's even a nice UI visualization of all the endpoints in my API Like if I just search here for Endpoints Explorer in Visual Studio and bring up this view, this is like a tree view of all the API endpoints that are in my app. And you can even do things like right-click on an endpoint and say, "Please generate a request for this endpoint," and that will add stuff to your HTTP file for hitting that endpoint. This is the same one that I already have, so it's kind of duplicated, so that doesn't really help. But if you had other endpoints, you could do that. And you can even like right-click and say, go to the code for that particular API endpoint so I can see its implementation. So this is an alternative way that you can test your API endpoints that's integrated with Visual Studio. Awesome. So that's really what I wanted to show. So we've seen the render mode API, we've seen the static web assets optimization, new open API support in ASP.NET Core. This is just like a tiny bit of the new stuff that's in .NET 9. If you want to see the full list, I'll point you to the release notes. So this is the What's New in .NET 9 top level release notes doc that you can find publicly in the .NET Core documentation. And this will cover the release notes for all the different areas. If you want to look specifically at ASP.NET Core for stuff for web developers, click on this link, and that'll bring you to the release notes for ASP.NET Core and .NET 9. And there's just tons of stuff. There's a new authentication authorization support. There's a new hybrid cache API. You can just go check this out.
I feel like we would need to do like a whole day of just what's new, but that's .NET Conf, and that's coming in November.
That's coming in November, yeah. Be sure to mark your calendar so you can see all the new features. So give it a try. Try it on Azure App Service, and let us know what you think.
Awesome. So Daniel, I need to give you the question that I usually get, which is, what is the difference between STS, LTS? Who should be looking at STS versus LTS? Why STS, etc.?
Great question. Okay, so that's the different support policies for our .NET 9 releases. Every even numbered release of .NET, and we ship one every year, a new major version every year. Every even numbered release is a long-term support release. And long-term support release basically means it's a 3-year long support cycle where we'll do security fixes and patch releases for that release for 3 years. And that release is really for people who need something that's a little bit longer, that can't quite move as fast, don't want to update with every single release of .NET, need a little bit more time, a little more breathing room. STS is standard term support, and that is basically an 18-month support window. And the idea with standards, you use standard term support releases when you're like, I'm just going to keep updating with .NET. I want the latest, greatest stuff. And so every year I'm going to update my apps to use the latest version. So that's when you use STS releases. .NET 9 is an STS release. .NET 8 was our last LTS release, and .NET 10 will presumably be our next LTS release. If you want to know all the details about the .NET support policy, you can go to the .NET homepage, which is what I've loaded here. And way at the bottom, you'll see the link to support. And then you can find the official .NET support policy, and this walks you through all the details about how long each release is supported, when it shipped, and when its support ends, and so forth, so you can manage the versions of .NET that your apps are currently running on.
Perfect. Thank you very much, Daniel. It's always a pleasure to have you, and I can't wait to get ready for .NET GA and party on the new bits.
November.
Yeah.
It's coming.
It's coming. And with that, I think it's time to talk to Jeff, who, by the way, I think he will be at .NET Conf. We usually have somebody from the App Service team because we do a bunch of work to get day zero support for .NET, and this year it's going to be Jeff showing up some stuff. I don't want to give too much away, but we have some exciting demos coming up for that as well.
There's the .NET Conf.
Yep, there we
Page.
go.
It's already up, so mark your calendars, November 12th to 14th.
We're going to be busy those days. Okay, Jeff. So, what are we going to talk about today?
Yeah, so today I wanted to go over app configuration references, which is a feature that we had recently announced to become generally available. And what this does is it allows you to add a reference in your web application environment variables, which will reference a single key value pair in your app configuration store. But just backing up a little bit, if you're not familiar with app configuration, essentially it's a service in Azure where you can store and centrally manage app settings and your environment variables. So if you have multiple apps in different places and maybe those apps all use the same app setting, then you could use and benefit from having an app config store where you could just centrally just update it in that one place, and then it'll update those multiple apps.
So the scenario here is, let's say I have 3 or 4 versions of my app, and they all have the same setting, and I want them to be synchronized. So I don't have to go to each app and change the value. I can just go to app config and change the value, and then the app will pick up the change, and they will always be on the same version of the config. So,
yeah,
and
yeah.
then
That's exactly right. And with the app config reference, if it loads up here, we have a particular kind of syntax. If you're familiar with
Sorry, Jeff, we seem to have a little bit of an issue there with your connection. I don't know if you're back.
Okay, I'm back.
Okay,
Yeah.
Here we go.
Sorry. Yeah, so with app config references, it works a lot like key vault references, if you're familiar. So you can see here the syntax is very much the same, where you have at Microsoft.app configuration, you reference the endpoint of your store, and then you could add the specific key, and then if you have a label, you'll add that in as well. And I'll go ahead and show a quick example of how this works. So here I have my app configuration store, where I already have a key value added. If we just look at the edit view, we can see that it's just a message, and the value is showing the message that app config references are now GA on app service. So we have this set in our store, and then if we go over to our coinciding web app where we're going to reference that value, and we click on the environment variable, we can see that the name is app setting key, and then we have that syntax that I just showed in the documentation. Again, referencing the endpoint of the app config store and the key. And for this scenario, it's quite simple. It's just, this is the value that's pulling through the reference from the app config store, and it's having the message send or printed on the page.
So then in your code, do you need to use a special SDK or anything like that, or how do you reference it?
Right. So I think a big benefit of the references comes from what is seen in the code. In this example, it's just a simple .NET 8 MVC application. And let me try to get this a little bit bigger. Okay. So all I'm doing here is bringing in the iConfig into a controller, and then using that config to reference the environment variable that's in app service. And then we're just passing it through view data onto the index page and printing out that message. So it's quite simple. Now, previously, if you're doing app configuration sort of the standard way, before we had these references available, you would have to bring in an app configuration package, and then you'd have to add a connection string, create models, and it's more of a heavyweight process than what you have to do now, which is just reference.
I think we lost you there again for a sec, Jeff, but we do have a question from the audience, which is from Xing Wu. Is app configuration package compatible with .NET Framework? And I think the point here is that if you're using app config, you don't need to have any special SDK or anything like that. You just reference an environment variable the way that you would reference it. And it doesn't matter if you're doing .NET Framework, .NET Core, Java, Python, whatever. You treat it as just another environment variable. There's no special SDK to install or use for this. Okay. Do we have you back, Jeff? Nope. I think we lost Jeff. But it's okay. I think we got the idea.
Yeah, back.
Okay. You have the app config resource. From your code, you can reference it as if it was just
for
variable.
I think you answered that question.
Yep. And then there's no special SDK to include with your app, which is the beauty of this. Sweet.
Yeah.
Okay.
So I think it definitely reduces the amount of code that you need.
Awesome. I think that wraps it up. Thank you very much, Jeff. We do have another community stand-up coming up on October 2nd. I will not be here for this, but I will leave you in the very capable hands of Denver. And Denver, you want to give us a little preview of what we're going to be talking about?
Hey everyone, sorry, my internet is not doing great today either. Apologies. What are we talking about in October? I believe October is Spring Boot and Java SE, specifically running fat jars on App Service. And if you can see me now, that's what I'll be talking about with Gregory. Sorry about that. Specifically running a really cool Spring Boot app, getting it deployed, configured, set up to run a fat jar on App Service. And I'll be joined by Gregory from the Java team here. It'll be a lot of fun. Be sure to join in for that one.
Perfect. Well, thank you very much, everybody. Thank you very much, Dan and Jeff and Denver. And we'll catch you on the next one.